Good morning, everyone. Welcome to the session, The New Wild West, Law, Regulation, and the Future of Space. Uh, we're here with Professor Christopher Impey, Distinguished Professor of Astronomy from the University of Arizona. Remember, you can leave your questions in the chat box and we'll read them at the end of the presentation. So thank you, Professor, and enjoy.
Okay, I'm very pleased to be with you. I was here last year. It's a great conference, and I'm going to give kind of a big picture view of the surging private space program and what it means for the future of space. So take a big picture view. I got into this subject some years ago. My research is cosmology, basically distant galaxies, but I could tell something interesting was happening, so I wrote a book about the future of space some years ago. And I'll just start up front. We know the positive things, but maybe there are some concerns. So let's look at those. When I talk to the people I teach, young millennials, 18 to 21-year-olds in the US, they're a little skeptical about space. They think we have big problems here on Earth, and they see billionaires with their boy toys, and they wonder why is this important? Then astronomers and space scientists know that space is essentially a very unnatural environment for humans. It's brutal. And so being in space is difficult. It's not a natural place for us. Astronomers and space scientists have argued for decades that to explore the solar system and even as close as the moon or Mars, it's just far better and cheaper with robots, and there's no safety issues there. We've done extremely well. Look at the rovers and robots that have been on Mars in the last half century, essentially. We also know that there's a downside for all this increased activity. Space junk problem is getting worse, and I'll talk about it briefly. And then the sociologists and anthropologists at my university sometimes bend my ear and say, this is not going to go well necessarily. It's such a weak, regulated environment that people will do bad things in space, and there'll be really no constraints on them. So those are legitimate concerns. When we look at the state of space, we have to remember that it's mostly been the work of the world's two superpowers at the time, with military and geopolitical motives. There weren't really altruistic goals of exploration and research. It's a small activity. Less than 700 people still have ever been into Earth orbit, and it's more than half a century since we went to the moon. So if you look from afar, you might wonder, well, have we really been progressing at all? But you can drop back and say this is something new. It's a new activity, it's difficult, and it's still in its early phase. So it's maybe too soon to judge, actually. People who criticize NASA, and they do quite often for not being visionary enough or imaginative enough, should recognize that NASA has had a declining share of the federal budget. Here we see the history of NASA funding since its founding. The spike for Apollo was obviously unsustainable, 4.5% of GDP, and then went into reverse very quickly with the Vietnam War ongoing and so on. But the last part of the curve is more dispiriting, which is that in real terms, the amount of NASA's budget for the federal budget has gone down by a factor of two in the last 2 decades. So NASA is trying to do more with less, and that's difficult. It also has a slightly different type of problem that NASA tends to only get into the news cycle when they need more money or perhaps for a bad reason because something blew up. Meanwhile, we have a new superpower rivalry brewing. There were 180 successful rocket launches to orbit in 2022, and the United States was dominant and has been dominant, but China is moving up very fast and has extremely ambitious goals in space. And there are concerns because their space program, unlike NASA's, where the books are open and it's a public agency where anyone can see what they do and why, um, China's space program is merged with their military industrial complex, and that leads to some deep suspicion that they may even potentially put weapons in space, although that's against the UN Treaty of 1965. So these are concerns, but of course the excitement is in the private sector, and we can remember that this started over 2 decades ago with some space tourists who spent tens of millions of dollars to ride the Russian rocket, because at that time the space shuttle was grounded, to the space station. Charles Simonyi even threw in an extra $15 million to do a spacewalk. But really, the moving force in the private space program was the X Prize, a very clever incentive prize where the teams that competed for the X Prize spent far more than the prize itself to do a repeat suborbital flight reaching 100 kilometers. And Burt Rutan, obviously, is the sort of supreme airplane and spacecraft architect of the late 20th century, was the designer of the device that won. And then, of course, he was poached by Richard Branson to form the spaceship company. So of these three high visibility players, because they're very high visibility billionaires behind each of them, a spaceship company and Richard Branson are probably bringing up the rear because these are suborbital flights. They also had a disaster. They lost a co-pilot and nearly a pilot. They had 3 deaths on the ground around that time. And so they've been set back for a number of years, but have a lot of expressions of interest. Blue Origin and SpaceX are much more familiar to us. They're funded by the two wealthiest people on the planet, who've each put at least $1 billion of their personal fortunes every year into this activity, and they are utterly committed to doing interesting and innovative things in space. And that's really what we're looking at now. These are the players, familiar to you, I'm sure. Not as familiar to everyone. Most people don't know Peter Diamandis, the founder of the X Prize Foundation, which has had a number of other challenge prizes. Branson and Musk like publicity, so we hear a lot about them. Jeff Bezos is a little more reticent. Yuri Milner has also put a large amount of money into the space activity, and you can look at these people and think, well, maybe you need a little Eastern European male pattern baldness thing going on to be a space entrepreneur. These new rockets are very big. Here we see the size of Elon Musk's Starship, which he abbreviates mischievously to BFR. And yes, that's what the F stands for in a big rocket. And these are rockets that are now exceeding the Saturn V in size, and for per launch cost, hundreds of times cheaper than Saturn V. So the reusability of rockets is a complete game changer in this arena. People will die. It hasn't happened yet, and there was a very high risk and high success mission, Polaris Dawn, just a week or so ago, with a spacewalk, done in vacuum. They had to evacuate the spacecraft. And so deaths and injuries have been rather modest so far. The model that the space program, the private space industry is hoping to follow is the commercial aviation sector, where here in the graph you see the fatality rate in civil aviation dropped by factors of hundreds in the first few decades after the 1920s, and now it's incredibly safe. So the private space sector will accommodate some risk. People sign very extensive waivers when they go up, but it is a dangerous activity. You're being strapped essentially to a high explosive and sent faster than sound speed with enormous forces operating on the rocket into Earth orbit. The economics are driven again by the entrepreneurial sector and by these rich people. The number of billionaires in the world is growing rapidly with the world economy, and the three players that I mentioned have put their own fortunes into this activity. And last time Forbes measured it, Bezos and Musk, their roles change depending on what Elon Musk has spent his extra money on recently, are the two richest people on the planet, and they run the two most successful private space companies. I decided that it made sense to analogize the space activity to entertainment and recreation, since that's part of the business model of these companies. And from available data, I was able to plot the average cost of a space mission and the average cost of a Hollywood movie since the beginning of the space age. It's quite interesting because these curves crossed about 5 years ago. The average movie now costs more than the average space mission. And if you wanted to do the analogy directly, I've circled Kepler and Avatar. So if you had $250 million that you really needed to spend, you could make a great movie by a famous director, James Cameron, about life on an exomoon, or you could build a mission, the Kepler mission, that found hundreds of Earth-like and potentially habitable planets. So the science cost as much as the movie, the same. That makes the science a pretty good deal, actually. If I wanted to further analogize, I'd look at the history of the internet. Compare it to the space program. And this may be a little artificial, but there are essentially 4 phases: the pioneering phase, incubation by the military industrial complex, a research phase, and then the commercial phase. You won't recognize the person on the lower left, J.R. Licklider. He wrote a position paper for the RAND Corporation in 1960, envisaging the wireless internet, data in the cloud, and that's at a time when computers were the size of a family home. And then most people who first got email accounts, of course, were working in government facilities, the military, and so on. It took a while for them to percolate. But there was gestation in the research arena. The web browser developed at CERN. And then 1995 essentially was the takeoff point for the internet. In 1995, two young grad students at Stanford figured out search. The first internet service providers were started, and a strange company that thought they were mostly selling books online called Amazon was founded. If the analogy makes sense, there's a pioneering phase in space too. Robert Goddard's little rocket at the top of that test stand traveled about 100 meters across his Aunt Effie's frozen cabbage patch in 1929. It's hard to draw a straight line from that to Saturn V, but that's what you do in only a few decades. Incubation by the military-industrial complex, obviously Werner von Braun, a slightly unseemly part of the space story, was surrendered to the Americans rather than the Russians. The Americans scrubbed his very strong Nazi connections. 5,000 of my countrymen in Britain died from the V-2 rockets, and another 7,000 or 8,000 died in the slave works that built those rockets. That's how the sausages get made. And then the research arena with the International Space Station, the Space Shuttle. And I think around about now, we're witnessing that same takeoff point because it's happening all around us. And we see the pace of progress is really fast. I'm talking mostly about big rockets, but the room at the bottom is important too because of miniaturization. So CubeSats and other miniaturized technology are severely lowering the bar to do interesting things in Earth orbit. So we now have student groups and private individuals and very small footprint operations that are able to do interesting science and research and surveillance and monitoring in space with CubeSats. You attach solar sail to the CubeSat, you can start to explore the solar system. But when you do this in large enough numbers, you create a problem. Elon Musk is voracious in his desire to have Starlink satellites up there. And so we're heading to 50,000 Starlink satellites. And the dramatic rise, almost exponential rise in the number of small satellites is creating a problem of space junk, as we know. And there's very little regulation in this arena. When it comes to the law, there have only ever been two international space treaties with UN signatories. The important one of 1967, banned weapons in space, was signed by the world's major superpowers. But the Moon Treaty is the only other one in 1979, and it was the only one that covered rights and space ownership. But it did not talk about private individuals or commercial companies. It was just state actors. And also, it wasn't signed by the major spacefaring powers, and that's still the case. So it essentially means there is no extant international law that applies to the space activity. Yes, the UN has working groups that are trying to move towards perhaps new treaty language and monitoring and control of space junk and other issues, but the UN moves at a glacial pace. And so those committees have been in place for a long time, and I haven't seen much out of them yet. Meanwhile, the space junk accumulates. Space junk is considered a tragedy of the commons, where everyone wants to exploit this new resource, this exciting resource of the near Earth environment, and they're willing to go there in large numbers with their objects and satellites, but nobody takes responsibility for the consequence. And sometimes bad actors, China and Russia, have blown up their own satellites as a test of anti-satellite technology and created thousands of pieces of debris. So low Earth orbit contains 35,000 tracked pieces of debris or defunct satellites, and about 1 million that are centimeter of pieces that are 1 million or centimeter or larger. And then the numbers are exponential. Of course, a millimeter-sized object, a pinhead-sized object moving at 18,000 miles an hour can puncture a spacesuit or the thin shell of a spacecraft. So this is a serious problem. The Kessler scenario from 1979, a NASA engineer, projects that if you can exponentiate the fractioning of debris into smaller and smaller pieces, eventually and possibly low Earth orbit becomes unusable. This is a pressing problem that we need to take care of. Governments are starting to take care of it. Private companies are being incentivized to develop mitigation strategies, but it's very difficult. It's big. Near Earth orbit is in a huge area and volume, and so sweeping up and cleaning up the debris is not something easily or readily done. Here's a little animation just showing how the Starlink satellites, again, Elon Musk is only one of the players in this arena. There are others, but he's perhaps the most aggressive in terms of the number of satellites he's putting up. They are causing problems to my tribe. The astronomy tribe of optical and radio astronomers is dealing with compromising of all the deep space images and the radio telescope observations because of the sheer number of these satellites. So astronomy is already being impacted. There's also the issue of contamination in space, and we try and take that seriously. And NASA has, to its credit, taken that seriously. They have protocols to try and sterilize spacecraft that head to another destination, especially the moon and Mars. And then, of course, there's extreme caution taken over backward contamination, as when the first Mars samples come back. Now, that timeline is pushing off with NASA because of the 12 billion and ballooning budget for Mars sample return. But eventually, samples will come back, and we'll be very careful with them. They'll be at level 4 biocontainment facilities in Johnson Space Center. But microbes can survive in space, even tardigrades, like visible-sized creatures, can survive the rigors of deep space. So we don't actually know what it would take to completely decontaminate or safeguard us from microbes, either going forward or going backwards. And then this sociological and cultural issue is significant. If nobody has any rights or ownership, then anyone can own anything. You can declare ownership of the moon, of Mars, of asteroids that you want to mine, and so on. And there's no regulatory apparatus to say that you can't do that. You could also use slave labor in space. I mean, I'm making a dire little scenario here, but it's possible because, again, there's no constraint. So in the American model, the question is, will it be like the national parks where we try and leave a light footprint and not alter these worlds unnecessarily and don't assume that we can just change them at will or completely savage them at will? Or is it going to be manifest destiny? And who decides? At the moment, it's just not clear who decides. And that's hence the title of my talk, The New Wild West. But this is changing, and it's moving very fast. Here are some of the records just set a couple of years ago. The most private investment in space, most successful launches, most people in space at once. That number still is a record, 14. And then the oldest and the youngest astronaut. Everyone knows the oldest astronaut because it's William Shatner, such an iconic person to eventually go into space for real. So this future that I'm projecting is actually here. Here are the history of launches, government and commercial, since the beginning of the space age. You can see the ascendancy of the superpower rivalry. And as we all know, the Russians made most of the early marks, the first satellite, the first human in space, the first woman in space, first spacewalk, first soft object landed on the moon, etc. So the Russians were ascendant through the 70s and 80s. And then the United States sort of took over after that. And now Russia is, of course, not poor, still has nuclear weapons, but a modest second world country. And China is ascendant, as you can see to the right of this diagram. What we can also see is the private sector, not just starting in the last 5 or 6 years when the press has been watching it carefully, but actually going back a few decades with a learning curve, has been active players. And now private launches routinely eclipse government launches in terms of space to Earth orbit. And here are the number of launches, successful launches to Earth orbit, and the record is essentially being broken every year of the most launches to Earth orbit since Sputnik. So the future is actually here. What's driving this, as I mentioned, is reusable rockets, and here's the cost per kilo of payload to low Earth orbit over the past few decades. And you can see in particular that in the decades of the 2010s, thanks to SpaceX's rockets, especially the workhorse Falcon 9, which has had almost 300 successful launches and just a handful of failures, has driven the cost down by a factor of 10 in just 10 years. That's dramatic progress. And of course, the Starship should continue this curve. If eventually we got a space elevator, getting to Earth orbit would essentially be free. But I think that's a bit of a dream for a few decades away. So the reusable rockets, still, of course, we're relying on, antediluvian chemical energy technology. Really, eventually, to leave the solar system, we absolutely will have to have new propulsion technologies. Chemical rockets simply won't cut it. But by squeezing as much as we can out of the chemical rockets we have and reusing them, we are bringing the activity of space down to a cost curve where a trip to Earth orbit will eventually cost no more than a nice cruise. And by eventually, I probably mean in 10 or 15 years. And at that point, you do open up a significant market. So what's on the horizon? Well, the moon, one of the few failures in these competitions for activities in space was the Lunar X Prize from Google. It was a challenge prize, not for governments, but again for small companies, student groups, universities, to land a rover on the moon, travel 500 meters, and send back data at either end. And that challenge was never met. They extended the deadline a couple of times. 16 or 18 groups were involved, and some came fairly close, but no one won the Lunar X Prize. So not every challenge gets met in this arena because it's difficult work, but it still spurred an enormous amount of innovation. But like I said, there's no rules on the moon, and so commercial activity and the worst nightmare for astronomers in not on the moon as much as on Earth orbit, but huge billboards in space and neon signs, that would be an astronomer's nightmare. So I'm being very self-interested here and talking about that as my concern, but it is a concern. And the space elevator, well, it's not really going to happen soon. We do not have material of sufficient tensile strength to do a space elevator on the Earth. And a space elevator, to remind you, is a cable that stretches well above geosynchronous orbit such that it is suspended by its weight against the centrifugal force of the Earth. And needs to be stabilized, of course. There are instabilities. And then you just have solar-powered lifters moving up and down, essentially carrying cargo to Earth orbit free. And that's a transformational thing. We can't build one on the Earth yet, but actually our materials at the moment are sufficient to do one on the moon with 1/6 gravity of the Earth. The cost estimate about $10 billion. And again, since the moon will be a staging point for commercial activity in the solar system, it's very likely that a lunar space elevator will get built in the next 10 or 15 years, and the cost is not prohibitive. And it will liberate another whole area of this activity. Mining asteroids is another thing that's talked about quite often. The economic models are a little tricky because obviously if you corner the market on something in large quantity, then you crater the price, as the Hunt brothers learned about silver in the 1970s. But there are many asteroids, near-Earth asteroids, about half a kilometer in size, which have several $1 trillion worth of platinum group metals and a similar amount of rare earths. And that's an enormous resource. And it would not be hard because NASA's with the Dawn Rendezvous mission has shown the ability to alter the trajectory of an asteroid. So bringing an asteroid into an elongated Earth-Moon orbit and then harvesting it at leisure is not impossible. I mean, the technology to do that is really clear. But again, the economics of that are very unclear. People will lose their shirts on this. The first space miners and asteroid miners will probably go broke. Also from asteroids, I'll point out, you get water, and water is a very valuable, essential commodity for operating in space. And so you get that as well if you judiciously select your asteroid. So I think this will happen, but it's a fuzzy timescale, maybe 20 or 30 years, my guess. And then Mars, yes, we will go to the Earth, we will go to the moon, we'll go to Mars. Mars, dramatically more difficult than the moon. It's a 8 months trip rather than a week. You're 50 million miles from the nearest hospital. So just setting up a simple base, let alone a self-sustaining base, is an enormous proposition. I know Elon Musk talks glibly about and recently about going to Mars with people within 4 years. I don't really think that's going to happen. And having a colony is a long way off. It's a very extreme hazard and difficulty to set up that infrastructure. Also, remember, Mars has two faces. Also, we will probably self-select. The people who go to Mars and our colonists will be genetic modifying themselves and accelerating hacking of their genome because they can, and to adapt to the Martian environment. So Mars has, as I mentioned, two faces. Mars can be beautiful. But Mars has a sting in its tail. And then there is the visionary project, which I should mention, Breakthrough Starshot, which is attempting to leave the solar system using nanobots powered by microwaves beamed up from the Earth on solar sails, so tiny spacecraft with solar sails attached. And a fleet of these would be heading to Proxima Centauri, accelerating to 5% of the speed of light. That's an 80-year journey, 4 light years away. And that's an extreme visionary project. There are many technical hurdles, but the groups behind this, who are not sufficiently well funded yet, only a couple $100 million sitting there in the kitty yet, are seriously considering what it would take to go to Proxima Centauri by this method. And I think this project will also happen, but there are again many technical hurdles. But very exciting. This is the first way we'd leave the solar system. Obviously not people. We need a new propulsion technology and suspended animation technology as well for people to ever leave the solar system, in my opinion. If you did have this capability, then you could colonize the galaxy or explore it with your nanobots in far less than the age of the galaxy, which brings to mind Enrico Fermi's question from 1950. Well, where are they? If we're on the cusp of doing this, then why would we be the first and the only to do this? So what are the prospects? I'll summarize here to finish. Yes, maybe recreation for the masses when that cost curve comes down. For people who are skeptics about space, a good reason to do it is that you demonstrate technologies that exhibit extreme self-sufficiency. And so it's a model for parsimonious living on our own planet. I do think we will eventually master the solar system in some sense. If we ever got a space elevator on the Earth, it would be amazing because we could solve the problem of toxic waste and radioactive waste by essentially sending it gently off the Earth towards the sun, fully solving that problem. And for the people in the social sciences, it is a fascinating experiment when you first have colonies off Earth. And for everyone in policy, law, ethics fields, it's a very exciting time because it's a clean slate and these fields are being built new. And so this is the end, I think, of the beginning, when there's plenty more to come. Thank you.
Thank you, Professor Impey, for a very thought-provoking presentation. And the slides were really attractive too. Is there any question from the public? If not, remember the presentation will be stored in the platform and they can write to you at other moment. No? And no question? Well, thank you everyone for attending the session and thank you to our presenter.
Yeah.
Now we're gonna have a break before the next session and we hope you keep enjoying the conference.